Okay, so here I'll discuss two important things. This may be unuseful for all of you who doesn't have exposure to R, right? And these are the two file format I'll discuss. First is textual and the other is binary. Why this file format is important? Because sometimes we need to store some files or data for a longer duration of time, right? And in that case, if we convert those file format to a textual or a binary file format, these are long-lived file, right? And there should not be any issue of corrupting those files, right? So that's why this is the use case I use way back, right? I guess in 2010 for my company, where we generally converted all the data in textual file format because the study was complete, right? And the team want to store those file. Okay, but here I'll show you basic functions, right? How to convert to maybe our data to a textual, right? Any binary file, right? Based on some function, and we can also retrieve, right? Trace back from a textual or binary file format to our original file format, right? So I'll show you various functions, how to convert to a textual and how to convert back to our original file format. Again, how to convert to a binary file format and how to convert back to our original file format. So these are the thing, and here I'll show you also how to establish the connection with the URL. That means, for example, if you have some data on a particular website, right, and suppose you want to retrieve those, so what you can do, you can establish the file connection or URL connection, and you'll try to after establishing the connection, you can very easily import those data, okay, or those records or those information that is there on the website. So I'll show you that. And then how to read a text file. So we have a function read lines that can very easily import or read a text file, right? Yesterday I showed a read.table option. I'll show you again one more option, and then at the very end I'll show you the establishing the URL connection that is used to import or maybe extract the information from a website. So these are the four things I'll cover. This is relatively a small class. Okay, so let me start from here. I'll just set the working directory because I'm using another laptop, so we don't have here. Okay, so this is, I can set the working directory location here. Okay, so first of all, I'll clean. There are a whole lot of objects, and then I'll set the working directory. By default, it basically points to a C drive. I don't want to full my C drive. That's why I'm sitting here. Okay, the next thing is textual and binary file format, right? So these are the file format for storing the data, and this is based on the unique philosophy, right? Which generally stores all kind of data in text. Okay, this is the simplest thing. Then we have two functions. The function is dput and ddump. These functions are used for converting any file format to a textual file format. These are the textual file formats are editable, okay, and then in the case of corruption or potentially so we can very easily recover, right? And also they are very less likely that those file corrupts over time. So that is the advantages. And the other advantage is this dput and ddump, right? These two functions preserve the metadata information. For example, it will store the data type of all the variables. It will store the object of the variable. For example, if you try to convert a data frame into a textual file format, so it will preserve the data type or object type, that is data frame, and also it will preserve the individual variable data type. Okay, so it will preserve the metadata. So pros are these are long-lived and comfortably recovered if get corrupted, and a textual file format works much better with the version control. This is also one of the additional feature. So for example, if you have some data that is changing over time because the study is ongoing, so you can convert those into a textual file format, right? Why? Because you want to store, and there should not be any potential issues of corrupting a file, right? So what you can do, you can convert to a textual file format. The advantage is those are long lived, and the second thing is you can trace very easily the changes, okay, using version control software. You can use like a subversion or git, right? You can use any and you can very easily trace. Okay, the cons is here. So this is cons or a negative part, right? So these are not space efficient file, but we can very easily resolve this issue. How we can resolve? We can just convert to a textual file format first, and then you'll do the zip. If you do the zip, it will basically reduce a size significantly. Okay, so we can very easily reduce the size. The part here is if you want to store a file for a longer duration of time, right? And because if you don't want to have, if you don't want to compromise, right, the issues of storing for a longer duration of time, right? And you're making sure that those files are stay or live long, right, without corrupting. Okay, so you can basically avoid, or you can basically ignore the cons part of having a large space. So you can very easily if your goal is just to store the file for a longer duration of time, you can ignore the space part. But anyhow, because now in a clinical trial settings, we don't have a very large space, right? So if we try to combine all the data sets what we have, it may come in less than a ZB, right? So you don't have any issue. But if you're working with the finance data, right, you'll have a whole lot of millions and millions of rows, right? Because this is creating every seconds. For example, if you try to pull one stocks data, or maybe S&P 500 or Nexus, Nifty or Sensex, so you'll have multiple or millions of rows. And in that case, if you try to convert those file format into a textual file format, it will have relatively large space. Okay, so this may be the issue, but in the clinical trial settings, we don't have that problem of space. Okay, so let me show you how to convert first. So first of all, I'll show you a data frame, the creation of data frame. So you can very easily use data.frame, then variable name you'll have to specify first, and here you have to specify the values. So I'm just storing this very small data. So first here I'm specifying ID. Here we have a bunch of values. Okay, I'm just storing this number inside the quotation. That means I'm storing this ID as a character data type. Then again, after the completion of that, I'll have to use comma, and then I'll try new variable name, and here we have the names. Okay, whenever we have more than one element that you want to store, you'll have to use this combined operator C. Okay, so this is the thing. Then here on the third variable, I'm just storing third variable as weight and fourth variable as height. So these are the all variable here. And now we have here student data frame where we have 7 student, their ID, weight, and height. The next thing is, if I show you the class, this must be a data frame. Why? Because I use here a data frame function for creating that, right? So this is a data frame. Then the next thing is how to convert this to a textual file format. So we have here the function dput. So whenever you have a single R object and that you want to convert to a textual file format, you can use this dput function. And then the structure is, you'll have to specify the object name here, and then you can specify the file name that you want to create. Okay, whenever you convert to a textual file format, it will basically create the R code. That's why here I'm using .r. Okay, so this is the file name, student underscore dput, and it will create our file for us. Okay, where it will create, it will basically store this file at this working directory location, because I'm not specifying the path. If you want to store at some other location, you can specify the path and it will store at that position. Okay, so let me show you. Okay, so it's It's okay here. We don't have any error and any messages, warning messages. So what I can do, I can go to this location. I'll check. Yeah, here, if you notice, this is the file that I created just now. And if I show you, this is the R file. Okay, if I double click, it will basically open here in an additional window. Okay, and if you notice, it is basically storing as a list object. Why? Because here we have multiple things that need to that it has to combine. Okay, so I already told, right, that it preserved the metadata information. So you can notice it is preserving here the class as a data frame. Also, it has ID stored, then name, then weight, height, and this data frame a row number, because it has how many rows total. Here we have 7 rows. Okay, so that's why it is also storing this row number, row names. First is NA. Why? Because here, if you notice, just beside ID we don't have anything, so that's why this is NA, and then we have 1 to 7. Okay, why we have capital L? Because these values are stored as an integer. Okay, so this is the way why it is storing as a list object, because it has to store multiple data type together. Okay, so this is the structure, how it preserve and how it stores if you convert any file format to a textual file format. Okay, so I'll pause. I'll just cancel that. Okay, I'll close that file, and then here, if you notice, we have a student. So what I'll do now, I'll just try to retrieve the file that I just created. So first of all, I'll just clean from here. Okay, so I can clean from this rm function. Yeah, nothing is here inside this global environment. What I'll do, I'll now retrieve the file that I just created. So for retrieving, what you have to do, you just have to use a dget function. So you can very easily recall, right? You can very easily remember. So dput means you are putting any file format to a textual, right? Dget means you are retrieving, you are just extracting, right, or converting back to a original file format from a textual file format, right? So getting means you are just extracting that, or you are converting, and put means you are just dumping to some other location into a textual file format. So very simple, you just have to use a dget, and here you'll have to specify the file name with the extension .r. Why? Because this basically gives this R code. Okay, and why are not specifying the path? Because this file is located at the working directory location, and that's why we don't have to specify the path. You can very easily import or extract. Okay, so let me run this, and here we have the student one. We have these 4 variable. Okay, and here we have the record 1 to 7. Now I can check the class. Class is data.frame. I can check the structure, and this is again a data frame having 7 observations and 4 variables, and these are the record we have. Okay, so this is the way how we can convert and retrieve back to our original file format, right? How to convert, you'll have to use dput whenever you have a single R objects that you want to convert to a textual file format. So you'll have to use dput for converting to a textual file format. You'll have to use dget for converting back to a textual file format, right? Converting back to our original object, right? And these 2 function is used in case of a single R object. Okay, so I'll pause here. Any question on this?
Yeah, the first question on line 22, you have a double bracket. Is there a reason you have a double bracket at the end?
No. So this double bracket, this one bracket is for closing this. Let me just write again. Okay, so this first bracket is just to complete the opening and closing parenthesis of this combined operator C, right? And this last one is for closing the opening and closing parenthesis of this data.frame. Okay, that's why I have 2 brackets.
Oh,
Yeah.
Okay.
Yeah, so we'll have to be very careful about this parenthesis because otherwise it will give an error. And the benefit of using RStudio, it will basically highlight the opening and closing parentheses, right? So you don't have to remember. So you just have to click, right? It will highlight, right? And you should check whether you close all the opening parentheses or not. Yeah.
Right, I got it. Thank you.
Perfect. Yeah. Anybody, any follow-up question?
Hi, Ranjit.
Yeah.
Single object means what?
Sorry?
Single object.
Single objects for here, if you notice, I just have a student data frame. You can have a vector. You can have maybe you can have numeric vector, character vector, anything. So if we are passing here a single object, it means single data frame, single function, single vector, that is called single R object. Okay. Suppose here I'll show you with the deep dump function. So here I'm just using two things. One is X, the other is Y. That means here we are passing two R objects. Okay.
Okay.
Yeah.
Thank you.
Perfect. Anybody? Any follow-up question? Okay. So I just want to cover here one function, although I'll cover that part in dplyr. So this function is called clips, right? This is similar to structure. It will basically, if you want to relate with SAS, it will basically extract. It will do the same function as of this proc content, right? It will try to extract the metadata information about the particular objects. So, but this glimpse function is a part of dplyr, right? So you first have to load and install dplyr package, and then you can use that. The benefit of using glimpse is, if you notice this, the output of str. So here it is giving data frame, then 7 observation 4 variable, then here the variable name, their data type, and then few observations, right? Same for name, weight, and height. If I use glimpse, so this structure is a little clean, right? So this is much more clean. This is just for a 4 variable. Let me show you with very large data, right? So I'll import one. There are various packages that is present in R that have various built-in data. Okay, so for example, one is parameters. I guess I'll have to load that. No, we already have. So this package has various ADSL data, right? How we can extract, maybe you can use this for your day-to-day practice. So you'll have to write just EX. EX is just a notation for example, right? So here we have ADAE, ADATTE, ADCM, ADLB, right? Suppose I need ADSLs. I can just press a tab button, okay? And then I can store this whole thing with the name ADSL. Yeah, so here we have ADSL where we have 400 observation and 31 variable. Let me show you the output of str. So if I use str on ADSL, this is our output, right? If you notice, this is not clean. This is hard to read. Okay. But whereas if I use glimpse here, so you notice the output is and the result is very clean, right? This is the benefit of this glimpse function, right? They'll have provide a very neat and clean structure. Okay, so this is all about this glimpse. Let me move here to this dump function, right? So I just showed how to convert any file format to a textual file format, right? So whenever you have a single R object, you can very easily use a dget and dput function, right? And you can convert. But what about when you have a multiple R object, for example, 2 vector, 1 data frame? So what you can do, you cannot use this dput function for converting to a textual file format. Okay, here we have a dump. We'll have to use dump in case of a multiple R object. So for example, let me create here X and Y. So we have 2 individual character vector. It can be anything. And for converting to a textual file format, you'll have to use dump. Then here you'll have to use this way, combine operator, because whenever you are specifying more than one object, so you'll have to use combine, because this is basically a wrapper. It will basically wrap all objects together, and then you'll have to specify the file where you want to specify the name that you want to store with. Okay, and that's all. So you can run, and it will basically create a file with name data, okay, at this working directory location. So let me show you. Here we have data. If I double click, it will open here in this R in the new window, and here it will have X and Y. Okay, in case of character data or in case of multiple R objects, it try to map the things as it is, not have the other structure, but internally it stores the metadata information, right? So these are the point. And here this is very simple because I just provided a character vector, right? So whenever anything is there inside the code, right, whether it is single or double, it is a character, right? So that's why it is not storing other thing, because this is obvious. Okay, so second thing is, suppose I want to store at some other location. So what I can do, I can specify the location, right? So I just have to change, because we don't have this R folder in E drive. So I have to specify at some other locations. Let me just store to this output, right? So I can copy this location, and then I'll just change. Yeah, so I can just specify, I can run this line. I will create a textual file format here. You can notice this is the location I just specify. So you can place it at any location. There is no issue. You just have to add the path. Okay. So what if, let me just remove these two objects, X and Y, and then I'll show you how to retrieve. Okay, so here we don't have X and Y. Suppose I want to read those textual file format. Okay, so here we cannot use dget function, because dget is just for a single R objects. So here I'll have to use source. Okay, so if you use source, what this does, it will bring both X and Y that is stored here in this data. Okay, it will bring all these two X and Y here inside the global environment. Okay, and now I can very easily use. Okay, suppose, so let me just clean everything. Suppose I use dget, right? Why? Because maybe I forget, I just missed that, right? And instead of using source, I can use I may use this dget function. So in that case, it will only fetch the first R object. It will not extract the other, right? It will not fetch the other. It will only fetch the first R objects. So let me show you the structure. You can notice it is just bringing the first one. Welcome to grade 1 line training, right? The Y is defined as the first place, right? So that's why it is bringing the first. It's not bringing this X. Okay, so this is the problem you'll face. So I recommend don't use this dget function in case if we have multiple R objects that is there in the textual file format. We'll have to use a source function. Okay. The next thing is, sometimes we'll have numbers, right? Numeric data. Okay. So in that case, if we convert to a textual file format, we'll basically have a loss of precision or loss of information. So that's why we try to convert to a binary file format. This is a complement to a textual file format. This is for efficient purposes, right? In case of numeric values. Okay. So let me create here a student data frame. Again, the same thing. I just mute this variable of name because this is character. Okay. And now I can show you this student. We just have 3 variable structure. All this one variable ID is character, number stored as a character data type, and then 2 are number. Okay, so let me just show you the example with a single vector. Okay, here we have a vector of age. Structure of age, this is number, all 5 values, 24, 28, 24, 31, 28, these all are number, right? So how to convert, right, to a binary file format? How we can create this binary file format? So here I'm just showing with the more than one, so we can also use, so one thing here I forget to mention. So if you have a single R objects, you can also use dump. right? But this in case of so here's for example, suppose I just remove this y, so you can use dump, but the other thing is not true. So for example, here in case of dput, you always have to have here a single R object. If you have multiple, you cannot use dput function. But the other thing is true here in case of dump. This dump is basically designed for multiple R objects, but if you have a single, you can very easily use dump and you can convert to a textual file format. Okay, so similarly here you can use a save for a single binary object. Okay, a single R objects or a multiple R objects, but this function save is designed for a multiple R objects. So here we just have to specify the object one by one, and then here you'll have to specify the file name. The difference with this earlier is, right, the textual file is here it has to specify, we have to specify this RDA. What is RDA? RDA is extension for R data. Okay, so it will not create a R code, it will create a different objects. Okay, so if I show you, so here we have this where it is. So you can notice this is the one I just created, students underscore save RDA. This is RDA file, this is our data file. This is a different file format. If I double click, it will not open directly, so I just have to choose. So it'll load, right? And if you notice, it basically uses this function load for bringing back, right? So because you can very easily open the R code, but for opening any RDA, you'll have to use this load function. Or if you double click, it'll try to run this function right at the back end. That's why we have this code chunk, right? And then it will bring the file that we have right under this file name student underscore c. Okay, and because we already have that, so it will basically overwrite. Okay, so let me just clean everything from here and then I'll retrieve that file. Okay, so here I can clean, so nothing is there here in this global R environment. Now I can use this load functions. Okay, so I can use so load function is used whenever we have a binary R objects, right? So I can run and it will bring student and age. Okay, and this is the same. So this is the base. So this is the reference here. In case of binary file format, you'll have to create using save function and you'll have to retrieve using a load function. Okay, and now I can very easily use this age and student data frame. Okay, so any question on this binary file format? Okay, so next thing is sometimes we have a very large number of objects. For example, we may have 20, 30, right? So it is relatively hard just to specify the object name one by one. So in that case, what we do, instead of just specifying the name, right? What we do, we try to store, right, the workspace, what is there inside this environment, right? And for that, we have a function save.image. Okay, it will try to store or try to convert all the things that is available in the current RStudio workspace. Okay, so let me create that. Let me show you the examples. Here we have C, X, and Y. And now here we have how many objects? We have 4 individual vector, right? Age, C, X, Y, and then student as a data frame. The total have 5. Okay, what I can do for storing the workspace or for converting all that is present here in this workspace to a textual file format, here we'll have to use the save.image. So it will basically store, it will convert back, right? It will convert everything here what is present in the global environment to a textual file format. And over there, you'll have to use a save.image. So if you use save.image, you don't have to specify the name. It basically uses all that is available in the current RStudio session. Okay, and then you can specify the file. The difference is here you'll have to use R data. This is again another file extension this is a file extension for our workspace. Okay, so let me run this. So it will create again at this working directory location, because I have not specified here the path. So we have here all underscore object, and this is our workspace. This is extension. Okay, so if I double click, it will basically open as R, right? And here I can retrieve all the objects using this sorry, not Q, I'll have to use I guess ls function. Yeah, here we have, you can notice age, C, student, X and Y, and these are the objects what we are having at the current studio workspace. Okay, so the thing is, this is the function save.image we'll have to use for converting all the things that is present in the workspace to a textual file format, right? And now how to retrieve? You'll have to use the same function load. You'll have to specify this file name with the extension. So it will load all the thing that is stored here in the object name, all underscore object. So it can very easily bring everything inside the global R environment or R workspace. Okay, so think next part is here. I have extensions. .r is for text file. This is similar to .sas. .rda, this is similar to SAS7bdat. So this is our data file extension. RDA, this is additional, right? So I don't so we don't have anything for in SAS, right? This is the extension for workspace. Whatever thing that we have here in the global R environment, right, for that we'll have to use this R data. Okay, so here we have, so these are the three file extension. I'll pause here. Any question, anybody?
Hi Ranjit, can we even save this data frames using this save.image function?
Yeah.
I mean the multiple, if we have that n number of data frames, then...
Yeah, we are saving the same thing. So whatever the thing that it is there, right, it will basically save that. Let me show you save.image. You can store here a data frame. Okay, let me bring that. Where it is, I can run this part. Here we have student, right? I can also bring this ADSL. Yeah, so we have ADSL, and if I run this save.image, it will bring all right here. So let me remove everything from here. You can use this brush, right? Or I can use this rm function. Let me just remove everything. So if you recall, now it will bring ADSL datasets, student datasets, and other full vector. Okay, so let me load this. Here we have ADSL, student, and also individual vector. Yeah, so you can store anything, whatever we have. You can also have functions here. For example, if you have functions, it will also store and retrieve back. Okay, so you don't have to remember, right? Whatever the thing that is there in the global environment, right, or workspace, okay, it will basically store all right together in a textual file format, and then you'll use this load. It will basically retrieve everything. Okay.
Yeah, I got it. Thank you.
Okay, perfect. Anybody, any follow-up question, thoughts, anything? Okay, now I'll move to the another function. This is called serialize. Okay, this is a function used to convert individual R objects into a binary file format, right? Because in the case of a single, it may have some loss of precision, right? So let me show you with this number, age, vector age. Okay, so serialize has, because if I show you the structure of serialize function, so here we have to use various unicoding, right? So this is the function. This is part of a base R. You'll have to use serialize. Then here you'll have to specify the object that you want to convert to a binary file format. Then the connection. This is a channel. It can basically use the normal file connections. Then ASCII code will have to specify. Okay, by default it uses, I guess, I'm not able to recall exactly. So we'll have to specify some ASCII key. but I'll not use that. I'll use a default structure. Then XTR, this is a logical operator if the binary format is binary representation is used, right? So this is some additional thing that we'll have to use here. You can also specify the version, right, that you want to use, right, with a different version of R. You can specify that if you want to be specific. Okay, I'll not use. So what this does, it will basically retrieve the version from this R environment. Okay, I'll just use serialize. Here I'll not specify any S key keys. Okay, I'll just use serialize and age. Age is the vector that I want to convert to a binary file format. Okay, so here if I run this, if you notice, this is structure. So this is okay. The most important part is the data type or class of this whole thing. And in the interview, people ask this very regularly, right? So if I show you the str of this, it will not be a number. It must have here a raw structure. So when you convert anything to a binary in the form of 0 and 1, right? It's a binary structuring, right? So you'll have a raw, because this is a code that machine uses. Okay, so the data type of any binary file format is a raw. Okay, this is a prominent interview question. Okay, so the next part is how to convert back. So if you notice, we have a whole lot of things, right? In the original, we just have 5 numbers, 24, 28, 24, 31, and 28. But any convert to a binary file format, we'll have a whole lot of number, right? We also have some alphabets, okay? But this is the way how it stores. So the next thing is, this is okay. This is fine. It will not have any loss of precision in case of a loss of information in case of a number. Okay, this is fine. But the part is how to convert back, because just having a binary number, you cannot do any kinds of mathematical evaluation. You cannot do mean calculation, median calculation, and all, right? So what you have to do whenever you want to utilize that information, you'll have to convert back to original, right, in the form of 24, 28, 24, 31, and 28, right, the original vector. And for that, you'll have to use unserialize, right? So it will basically provide the original values that this age vector is having. Okay, so this is the way of converting back to original. Okay, so similarly, you can basically, so you can check the file structure, right? And this is all about the textual and file format. I'll show you the other functionality of establishing the connection with the outside world. So I'll pause here. Any question, anybody so far?
Hi, Ranjit. Could you please elaborate about serialize?
Yes.
Actually, a bit confusing. Age is only 5 and binary, lot many. What is the use?
This is the binary conversion. So I hope you study very early, right? When we study any programming language, so they basically helps in converting in the form of 0 and 1, right? So we have to use some way of maybe 2 to the power something, right? We'll try to convert the values. So this is one way of converting to a binary file. Binary file format is the original file format that any machine can understand. Okay, so that's why here we have bunch of zeros and 1, right? And I'm not able to recall exactly the formula, but you can check. To binary. So so you can notice, suppose you have a number 30, yes, for example, you have a number 0. So the binary representation, the same 0. As number 1, binary representation will be 1, right? In case of 2, the binary representation become 1 and 0. Okay, so similarly for the 3, the binary representation become 11, right? So how it works, because here we have a 10 for 2, 1 for 1, so we'll have to just combine these two things together. Okay, similarly, we may have some formula here. Yeah, so you can notice, divide the given number 30 repeatedly by 2 and until it's give a quotient as 0 as a quotient, right? So we'll have to divide this 13 by 2. You'll have 6 as a reminder, 6, okay, and 1 reminder. So you'll have 1 at the unit place. Then you'll have to divide this 6 again by 2. You'll have 3 here and 0 reminder, so you'll have to place here a 0. Then you'll have to again divide this 3 by 2. You'll get 1, and the remainder is equal to also 1. So you'll have to just use the reminder. So here we have a 1, and then you'll have to again divide this 1 by 2. You get 0 here and 1 as a reminder. So I'll have here these values 1 1 0 1. Okay, so I'll have so if you just convert this 13 right to a binary format, you'll have values as 1101. So I guess this is the way how convert. I'm not sure to recall exactly, but we can check some algorithm.
Ranjit, it's something called as an LCM, which we use.
Yeah. So LCM methods also. So this is basically LCM. We are basically doing the LCM, right?
Yeah.
Yeah.
Least common factor.
Correct. Yeah, correct. But the main important part is it can very easily convert. There is maybe some mathematical operation going inside, right, in the backend. But the most important part is in the interview they ask what will be the data type if you just convert anything into a binary file format. So it will be a raw. Okay, this is very important. Okay, because in the most of the time you don't see this raw as a data type because we try to use the actual values, right? Not the one that the machine can understand. Okay, hope this makes sense.
Yeah, thank you.
Okay, so next part is how to establish the connection with the outside world. So I already yesterday I discussed a few functions: read.table, read.csv, right? Read_csv. But I'll show you how to establish the connection with the URL or with the website. So for that, so if you want to import anything from external drive or from a web, you'll have to establish the connection, right? So we can have two kinds of connection. You can have a normal connection and you can have a URL connection. So normal connection works whenever you are importing any files from external drive, right, or maybe some other location. But whenever you are importing any files or any information from the website, you'll have to establish this URL connection. Okay, so these are two broader classification, right? The file connection for any file, right? URL is for a web page. We also have two additional collection. For example, you have a compressed file. And compressed file can also have a further categorization. You can have a zzip algorithm and then bzip2 algorithm. So for that, we have a dedicated file connection. So we'll have to establish zzip file connection in the case of compressed file with this zzip algorithm. So how the compression of any files works, right? So they have to do some inherent algorithm, right, for compressing that file. Okay, because anyhow they just have to reduce. Okay, but they have to follow certain algorithm, and these are the algorithm zzip and bzip2. So if we have file with compressed with the zzip or bzip2 algorithm, so you'll have to use their dedicated functions for establishing the connection. So these are the two. It's these two functions specifically used for compressed file, right, with the algorithm zzip and bzip2 respectively. But most of the time we use file for importing any normal files from external drive. Okay, and URL we generally use for connecting with the web page. Okay, so let me just explore some functionality of this file function, right? So if I use the str, it will basically provide us the source code, right? This is the source code for this file function. Okay, so here these all are okay. These are some encoding and other methods, right? But the method is very important. This last bit that I'm highlighting here, if you notice, we have two methods. One is URL methods and the other is default. So in case of any normal file, basically have to use it. It has a default as a method, right, for importing or establishing the connection. But for the web page, right, you'll have to use explicitly this URL connection. Okay, so we can establish the read-only connection, we can establish writing connection, we can establish appending connection. We can also have a read binary file, writing binary file, and appending binary file connection, right? So B is for binary file, R is for reading, WB is a writing binary file, AB is appending. Appending is basically a setting. Okay, you have two objects and you're trying to set, right, or append. So you can also establish that. Okay, so this is basically an extra layer of control that we are giving to a user. Okay, our extra layer of control that we are imposing on the user, so that they cannot do any kinds of manipulations or update. Okay, so let me, so we have here, I have to first establish, I have to dedicate the location. So dummy_txt, this is the file that I want to establish the connection. And for that, I can basically first specify the location here. So I can specify the location, and then I can copy this location. I can paste here. I can paste here in this setwd command. Yeah, I can just change this location now because I want to import this file dummy_text, right? And that file is located as working environment. So I can make this double. This is again another way of setting the working directory. Okay, so right now this is in D drive, right, at the different locations. Now I'm just setting to this folder, right, because we have this data. Okay, this is okay, and now I can establish the connection. So for example, if I show you this folder, we have here dummy_txt. This is a text file. Okay, so first of all, I'll just try to establish the connection, file connection, and then I'll show you how to import. Okay, so here the file connection, you'll have to use file, then here you'll have to specify the file name, because this is a text file. That's I will also have to specify the extension .txt. Okay, I want to establish here a open connection as a read only. Okay, so I can use R, small letter R, for establishing the read only connection. Okay, so let me run this. So here we have the object C. This is a file int4, that means it have 4 information. Let me print that. So this is basically extracting the metadata information about this object C, right? So this is a connection with the description. This is a file connection. It is mode is R, small r. R, it means it can read, okay, but it cannot write. Okay, and then extension of the file type, this is a text file. Okay, so because here I established the connection as a read only, that's why here we have the information: can read, yes; can write, no. Okay, and the next thing is, suppose I want to import. So what I can do, I can use dedicated function for importing text file. So yesterday I showed a read.table, and I can specify this C. Okay, and we'll basically bring that objects, that's text file dummy_txt here in global environment, in this console. Okay, suppose I want to store, so I can just maybe give some name, dummy_txt. Yeah, sorry. Okay, I don't know why this is. Yeah, we can give any name and we can store that. Okay, so this is the way how this works. Similarly, we can also establish the other file connection. Yeah, you can establish this in one go, right? You can write this whole thing, read.table, and here you can specify the file, right? And this I discussed yesterday. In one go, you can very easily establish the connection and you can import, right? And you can print here. But you can do piecewise. You can first establish the file connection, right? And then you can use read.table for importing that file. Okay. Similarly, you can also do a connection with other file format. This is not only for a text file, limited for a text file. You can also have you can also establish the connection with the CSV and Excel and other file format, right? For example, here this is a CSV. Same thing, you just have to change the extension here, right? And you'll have to use a dedicated function for importing the CSV file. This is the base R function. You can also use the read R function, read underscore CSV, for importing the CSV file, right? So let me show you. Again, here I established the read only connection. That's why it is giving here can read yes, can write no. Okay, and it can very easily import. Okay, and you can do in one line. This is to us, there is no issue, and you can very easily import the file. Similarly, this is not just limited to read only connection. We can also establish the writing connection. So you just have to use W here, small w, and establish the writing connection. So you can notice here, can read no, can write yes. So this is because I established here a writing connection, and I can use a dedicated function because this is a CSV. So I showed here read.csv. This is base R function. Now I'll show you a read underscore CSV. So first of all, I just have to load this read R package. Yeah, because I already installed. So installation you'll have to do a single time, and then you can very easily use this read.csv for importing that CSV file. And here we have, yeah. So whenever you are using this read underscore CSV, it will basically create a table, right? That's why here we have the first we have a variable name or object name, and then we have a column name, and just underneath that we have a data type. But you'll not have that thing in case of other normal data frame. You just have a variable name or a column name. You'll not have a data type shown here. But this is the speciality of table objects, and whenever you're using any advanced or functionality, it try to create a table, right? Because those are efficient, and those are having some additional feature. One of these is it will basically shows the data type of a respective variable underneath. Okay. Any question, anybody? So far I cover a whole lot of things. These are basically related to a study class, right? But we can very easily or control the access. You can use read only, you can use writing connection, right? Based on the confidentiality of a particular file format. Okay. Anybody, anything? Okay, so similarly, I have another file, I guess. Do we have energy data? No, we don't have that. Yeah, so here, let me, I guess we don't have this energy, renewable energy file. I guess it will not import. Okay, let me check. Okay, this file is not there, right? Where it is, yeah, renewable energy. So you can use other file, right? This is just another example, right? And you can very easily utilize. This is again the same thing, just using a different file. Okay, so let me show you how to import the Excel file. So yesterday I showed, right? This is again utilizing another packages. Okay, and here you'll have to install this package if you have not installed yet. Installation you'll have to do for a single time, right? And then you can load. So you can load this using this library option because yesterday I installed. Okay, and then you'll have to use a read underscore Excel function, right? And then here you'll have to specify the file name with the extension. This is very important. You'll have to always specify the extension of the file, and then you'll have to run, and it will basically import this file pop underscore df. Yeah, here we have it's population file. Then you can check data type and all. For example, this file is located at some other location. You can very easily import that, right? So let me just, I guess I don't have, I can copy this file in some other location, and I'll try to show you how to import. For example, I can paste here, and then I can copy this location. I just have to change that location before the file name, right? So I can paste that location, and the other thing is I'll have to make this slash, right? I'll have to make here a /. Okay, and now it can very easily, here the file name is population, not population1. Yeah, and here we have CC where we have same 483 observations and 12 variable. Okay, so these are the normal connection that we can establish with any file format, right? You can also have this SAS file format, right? You'll have to use Heaven package. Let me show you that. So for establishing or for importing the SAS file, anyhow we'll use that function very regularly, right, when we do the part 2 of the course. So this is the package that requires for importing the SAS file or establishing the connection with the SAS file format. So this is for SAS file, SAS datasets, right? So SAS data have extension SAS7BDAT. So let me show you. I guess we have here the SAS data in the project folder, the Adam data, and here we have a bunch of data. Let me specify this location. For importing that, what you have to do, you just have to use read_SAS function. Yeah, one thing, if you have not installed this package yet, you'll have to use install.package, and you'll have to specify inside the parentheses and quotation the package name Heaven, right? I have installed already, so I just commit that part, right? Those who have not installed, you can uncomment this line and then you can install first, and then you'll have to load, right? Installation I'll have to do for the right, always first, and then you'll have to load. Yeah, and then I can use a read_SAS. This is a function that is a part of Heaven package. Yeah, you can notice this is a function name. We also have read_CSV. Yeah, so this is coming from this reader. This read_SAS is from Heaven. SAV, this is again another file format. Then SPSS, right? Stata, TSV, this is a function that is a part of Heaven, part of reader. So you have Stata, you have SPSS, SAV. I'm not able to recall what this SAV means, but this is again another file, right? File format that you can import in our environment. Yeah. So right now I'll use SAS. Okay, and then here I'll have to specify first the quotation, and then you can paste the location of the file. I can make this double, either double, or I can change this slash to a /. And then at the very end, I'll have to specify the file name. Suppose I want to import the ADSL, so I can write ADSL dot SAS7BDAT. This is a SAS file extension. Okay, and then here I'll have to specify the name. So because this is ADSL I'm importing, so I can use ADSL. And here we have, where we have 116 observation and 55 variable. And this is the case study data. Yeah, so we'll use anyhow this function read_SAS regularly, right, when we do the part 2 of the course. Okay, so the next thing is okay, I'll just put that part before here. SAS data. Okay, so I'll pause here. Any question, anybody?
What is the extension for our dataset, like same
RDA.
RDA. RDA.
Yeah. Here I guess I mentioned here data.
Yes, it's correct. Yeah.
Okay, the next thing is how to establish the URL connection. Yeah. Anybody, any follow-up question, thoughts, anything? Okay. So how to establish the URL connection? So why we have to establish the URL connection? Suppose you want to import or extract some information from the page or web page. So same thing here, instead of file, you can compare, right, the difference. So earlier here you'll have to use file, then I'll have to specify the file name with extension, and then open is equal to R or W, right, based on the access that you want to give. For the URL, you'll have to use just URL. Then here we don't have to specify the file name, we'll have to specify the web page. Okay, this is a Johns Hopkins University page, right? I'm using this is just for example, and here this is the open is equal to R. So let me establish the connection, and here I can print. This is basically a metadata information. So this is again same thing. I'm establishing read-only connection. Yeah, and the thing is, suppose I want to read the text from this URL. So for that, you'll have to use a read line function. Okay, for reading the text from a web page. Why? Because any web page have some inherent language, and that language is called HTML. Okay, so that's why we'll have to use this read lines. And what I have to do, I just have to use this read lines. We'll have to be very careful. Here we'll have to use L lines with capital L, right? So this is sometimes looks weird, right? But this is the way how this works. Sometimes we have function with capital letter, right? For example, a view function. Yeah, so if I use here ADSL, I'll have to use capital V. So what this does, it will basically open the datasets here in the editor window. So here also we have capital V. Again, read lines. Then again, call means. I'll show you this function. These are the function for evaluating the column means. Similarly, row means. So they created this function with capital letter. This is basically called camel case. Not exactly the camel case, but they just created this function just to emphasize a certain part. Okay, so that is the thing. So we just have to remember this part, right? And if you do on a 2-time practice, right, you can very easily recall. So you'll have to use read lines. Then here you'll have to specify the object that you created based on this URL connection. Okay, what this does, it will basically import, right, and it will basically yeah. So here error initialize cannot read the connection. Okay, so let me try this. Okay, why? Because I waited for a longer duration time. That's why it fails. Okay, and here we have this imported, and here we have this x. X is a character where we have 2842 element. This is basically a HTML file. So let me print. I'll not print all because sometimes this freeze. Okay, because the HTML file format is relatively heavy, right? So it will slows down your system. Right now I'm using 24 GB laptop, 24 GB RAM, but still it slow down. Okay, so what I'll do, I'll just import top 6 records, and here we have, right, you notice this is stock type HTML, right, then class and other thing. Let me just try importing all in one go. So it will take some time. Yeah, right now it's just showing up to 23 line number, right? It is importing, so we'll have to wait. Meanwhile, if you have any question, you can ask me. Yeah, so it has extracted till row number 158. Yeah, please.
Once like you are extracting the web data, right?
Mm-hmm.
So like in which format we will be getting this the data?
Yeah, so it's getting in HTML file format.
Okay, then we have to convert it to our required format, right?
Yeah, so we'll have to clean that based on, because it will not have information, right, what we generally process in file settings. So we'll have to clean that. I'll show you maybe some other classes. We have a functions. I'll show you the process how we can clean and refine those data based on our requirement. Okay, so I'll show you. Because in the HTML also we have different structure. I'll show you here 3 websites. One is Great Online Training, Wikipedia, and Johns Hopkins, and you'll notice we have a different structure. Okay, so that is the problem. But anyhow, because why this is important, because right now you may not be using this function, but maybe the induction of a real world evidence, these may be prevalent functions we'll have to use. We'll have to extract the data from a page, for example, WHO page, right? Or maybe UNICEF and other open source, right, where we have informations. So there might be the case I will have to import or utilize the data that is out there. Okay, so then we can utilize this function. Okay, so it is taking more time. So so if you notice here, we have a button on the top right corner. We have a stop button. That means it is extracting that. Okay, so I'll wait for a few more seconds, right? So here, these many data extracted. So I can show you. So let me just open this John Hopkins website here. JHU dot what is the URL? jhu.edu. Okay, so it's imported everything here, and we have all information here. Okay, so we have everything here, and the next part is we just have to link, right? So let me just open this page first so that I can show you. Okay, this is the page, John Hopkins University, and if you go further down here, we have various button, right? Undergraduate admission, graduate admissions, virtual campus tour, Hopkins in a community, Hopkins around the world, diversity and inclusion at Hopkins. Okay, so let me just split my screen and then I'll show you how it is extracting the thing. Okay, I'll just show you the console. So let me, oh sorry, yeah. So here we have, I'll go at the top. Yeah, so this is the first page, right? Doc type HTML. That means this is a HTML file format. If I go further down, we'll have a various information. These are not required because they just use HTML language for creating that this page. I'm not expert in HTML. I also have a little understanding, right? I'll just try to link where we have the information that I just showed here on the page. Okay, so if these are the thing here, if you go further down, we have informations where it is here we have let me go okay, it is let me just make this in a full page and then I'll highlight that. Okay, yeah, so here if you notice, we have Explorer, diversity and inclusion at Hopkins, right? This is the label that it is highlighting, right? We have other informations, right? This is just to showcase a particular button in a specific way. Okay, if we go further up, right, we have here Hopkins around the world. This is the same whatever we have here, Hopkins around the world, then Hopkins in a community, then other tab. Okay, then here Hopkins in a community, and then campus tour and other tab. Okay, so this is the way how it basically imports, right? And yeah, so whenever you are trying to rerun, right, you're practicing, I recommend don't run all in one go, otherwise it will basically freeze, because this is a very complex structure, and because of that it will basically slow down your system. Okay, so try to use this head function or tail function where it will basically extract the first 5 records or 10 records. By default it extracts first 6 records. Okay, so I'll recommend right, that method. Don't run all thing in one go, right? Otherwise it will freeze. Okay, so what I'll do, I'll just showcase the same thing with our Create Online training website, and here I'll import using the read line connection. This is getting slow. Okay, so I guess it is running. Yeah, so it is complete now, and here we have a warning message. Why? Because this page may have some incomplete section. Okay, so that is okay, we don't have to worry about that part. I can now read that. Yeah, so I already imported using this read line connection, and now I'll extract the first 10 record from the top. So I'll use head function, and I'll modify n is equal to 10. So it will basically extract first 10 records, right? And here we have the information. So it is extracting that. Yeah, so here we have, and if you notice, this structure is little different, right, to the John Hopkins. Why? Because there might be the case that this website, right, the inherent language, right, the HTML language that they use may be different, right? The style of coding is different. That's why you can notice this is a little different, right? So this is the way, but anyhow, this is again a HTML file format. Yeah, so here at the very top, this is doc type HTML, and we have this structure. Because if you notice, this is important. So the first line is doc type HTML. The second line is doc type this language, English US, right? The third line, if you notice, this third line is very big. That's why it basically frees your system. Okay. So because if you notice, these are a part of row number 3. Okay, it's all are a part of row number this. That's why it basically slows down because of this complex structure, right? Till here, right? We have line number 3, then line number 4 is here, 5, 6, and so on. Okay, so this is the way how we can read, and I'll show you how to refine this information, how to extract the meaningful information from any text file or any web page later. Similarly, here we have another example. We can again establish the connection with the Wikipedia. Let me just clean everything from here. I can clean this also, right? And now I'll establish the connection with the Wikipedia. Yeah, this is complete. Now I can import this file. This is Wikipedia also has some incomplete lines, right? That's why it is giving warning messages here. But this is okay. There is no problem. And now I can import the first 6 records using this head function. Right here, we don't have big structure, right? That's why it's imported very quickly, right? So you can notice this is relatively simple, right? But the other pages, right? For example, this one or in conference, right? It is very complex. So what I want to showcase here, so all websites have different inner structure, right? Although they are using all are using HTML file format or HTML language, right? They may have a different structuring or different connotations. So that's why we have to refine in a different way. Okay, we have here one file, a text file basically that is stored here with the name. This is unfortunate homicide data. Yeah, you can notice this is the data. I'll show you how to refine and how to extract the meaningful information. For example, this is the one record, row number 1. If you notice here, we have a longitude, latitude. Then this is maybe an indicator for homicide shooting, right? Here we have the name of a person, address, then here gender, age, then death date, and victim died at shock trauma. This is a cause, and cause of death is at the very end. For example, I want to extract this cause of death. Cause of death is here. So what I have to do, I just have to remove everything that is appearing at before that cause, right, and after that shooting, and then I can extract that. So I'll show you that extraction or cleaning up information in a later session. Okay, so these are the things I just want to cover in this session. I'll pause here. Any question, anybody?